Dr. Anna Reeves had spent most of her life studying patterns in the deep sky, but nothing in her career prepared her for what appeared on the long-range observation grid that morning. The readings did not come as a dramatic alarm or a sudden flashing alert. Instead, they arrived as a slow distortion in the background data, like a faint noise that did not belong in a quiet room. At first, she thought it was a calibration error. She checked the system logs. Everything looked normal. The satellites were functioning correctly. The sensors were stable. Yet the pattern remained. A vast region beyond known mapped space was showing structure, something large, organized, and too precise to be random space dust or gravitational noise. Dr. Reeves called for a full system recheck. That was when engineer John Hale entered the control room. He was known for being calm even when systems failed completely, but as he reviewed the incoming data, his expression slowly changed. He leaned closer to the display, as if distance would make it clearer, but it did not. The anomaly was not small. It was enormous. It stretched across space in a way that did not match normal cosmic objects. It did not behave like a planet, star cluster, or nebula. It also did not behave like any known artificial construction. It was too structured for nature, yet too strange for engineering. John Hale ran manual verification scripts. The results repeated the same contradiction. Every measurement system agreed on one thing: the structure existed. But every system also disagreed on what it actually was. Anna Reeves watched quietly, her mind already racing ahead of the data. She zoomed in on different sections of the readings. The pattern was not static. It had layers. Each layer seemed to fold into another, like dimensions stacked inside each other. When she adjusted the sensor focus, the structure appeared to change shape, not physically, but conceptually, as if the act of observing it altered how it presented itself. That was the first moment she felt uneasy. John Hale finally spoke, breaking the silence. He said the sensors should not be capable of producing such consistent contradiction. Either the instruments were failing in a coordinated way, or something was actively interfering with observation itself. Neither option made sense, because the interference pattern was too structured to be random failure. Anna requested raw data from all observation satellites in the sector. Within minutes, the combined feed confirmed the same impossible result. A vast, organized structure existed far beyond known human exploration limits. It was not emitting signals. It was not reflecting light in any familiar way. It was simply present, like a shape that existed outside normal understanding of space. As more scientists joined the analysis, the confusion grew. Some suggested it might be a previously unknown natural formation on a cosmic scale. Others argued it could be a relic of an extinct alien civilization. But neither explanation fit the stability of the structure. It was too precise, too balanced, and too consistent across all measurement systems. Anna Reeves stood still in front of the main display. She noticed something others had missed. The structure was not just large, it was organized in repeating mathematical patterns that seemed to shift slightly depending on the angle of observation. It was as if it was aware of how it was being viewed. John Hale noticed her focus and asked what she saw. She did not answer immediately. Instead, she replayed the observation logs several times. Each replay showed a slight difference in pattern alignment. It was small, almost negligible, but it was there. Finally, she said that the structure was responding to observation. Not physically, but in the way it presented data. It was not reacting like a machine with sensors. It was reacting like something that understood it was being studied. That statement caused silence in the room. No one challenged her immediately, but no one agreed either. The idea felt too strange to accept quickly. Within hours, the data was sent to multiple Earth science centers. Independent teams confirmed the same issue. The structure existed, but it could not be described in stable terms. Every attempt to define it caused small changes in the results. It was as if definition itself was unstable in its presence. As night fell on the observation station, the team gathered in quiet discussion. The official systems had begun labeling the anomaly with a temporary classification code, something neutral and meaningless at first, Cosmic Domain Apparatus. It was not a name based on understanding. It was a placeholder for something that had no clear identity. John Hale leaned back in his chair, staring at the screen. He said that in all his years working with space systems, he had never seen data behave like this. Usually, strange readings could be traced back to error, interference, or unknown but explainable physics. This was different. It did not feel like missing information. It felt like information that refused to settle into a single form. Anna Reeves stood still in front of the main display. She noticed something others had missed. The structure was not just large, it was organized in repeating mathematical patterns that seemed to shift slightly depending on the angle of observation. It was as if it was aware of how it was being viewed. John Hale noticed her focus and asked what she saw. She did not answer immediately. Instead, she replayed the observation logs several times. Each replay showed a slight difference in pattern alignment. It was small, almost negligible, but it was there. Finally, she said that the structure was responding to observation. Not physically, but in the way it presented data. It was not reacting like a machine with sensors. It was reacting like something that understood it was being studied. That statement caused silence in the room. No one challenged her immediately, but no one agreed either. The idea felt too strange to accept quickly. Within hours, the data was sent to multiple Earth science centers. Independent teams confirmed the same issue. The structure existed, but it could not be described in stable terms. Every attempt to define it caused small changes in the results. It was as if definition itself was unstable in its presence. As night fell on the observation station, the team gathered in quiet discussion. The official systems had begun labeling the anomaly with a temporary classification code, something neutral and meaningless at first, Cosmic Domain Apparatus. It was not a name based on understanding. It was a placeholder for something that had no clear identity. John Hale leaned back in his chair, staring at the screen. He said that in all his years working with space systems, he had never seen data behave like this. Usually, strange readings could be traced back to error, interference, or unknown but explainable physics. This was different. It did not feel like missing information. It felt like information that refused to settle into a single form. Anna Reeves remained focused on one idea. If the structure changed based on observation, then understanding it might require a different approach entirely. But she did not say that aloud yet. She was still collecting thoughts, trying to see if the idea held any logical ground. Outside the station, space remained silent. But for the first time in recorded human observation, silence no longer felt empty. It felt occupied. And somewhere far beyond the reach of known stars, the cosmic domain apparatus continued to exist, watching, stable, and still waiting for humanity to decide how to look at it. Dr. Samuel Price had always believed that the universe followed rules. They might be complex, hidden, or difficult to measure, but they were still rules. That belief started to break the moment he examined the data coming from the cosmic domain apparatus. At first, it looked like a normal deep space anomaly report. His team sent him readings of gravity shifts, radiation levels, and spatial distortion maps. Samuel expected inconsistencies, as always happened with distant unknown objects. But what he saw was not simple inconsistency. It was something far worse. It was contradiction that changed every time he looked at it. He opened the first dataset. The numbers were stable for a few seconds. Then, without any new input, they changed. Not randomly, but in a structured way, like the data was correcting itself. Samuel froze. He refreshed the system. The original values returned. Then again, they shifted into something new. He leaned closer, thinking it was a display error. But the backup system showed the same behavior. Even the raw sensor feed was unstable. It was as if the data did not want to stay still. Samuel called for full diagnostic checks across all instruments. Engineers ran system tests, replaced filters, recalibrated sensors, and isolated communication lines. Everything came back clean. No malfunction. No interference. No signal corruption. Yet the readings kept changing. Dr. Anna Reeves joined him in the analysis room. She watched silently as Samuel replayed the logs again and again. Every replay showed a slightly different result. It was not just data instability, it was selective instability. Certain values changed while others remained fixed, as if the system understood what parts mattered most. Samuel rubbed his eyes, trying to force logic into the situation. He had seen sensor drift before, even strange cosmic interference. But this was not noise. Noise was chaotic. This was structured. Almost intelligent. At one point, the gravitational readings near the object showed impossible fluctuations. According to the data, gravity was increasing and decreasing at the same exact location, at the same time. That alone should have been impossible. But worse, every instrument agreed with it, even though it contradicted itself. Samuel tried to isolate a single sensor. When he did, the contradiction moved elsewhere in the dataset, like it was avoiding being pinned down. It was not just changing, it was escaping definition. Anna Reeves finally spoke. She said it felt like the object was reacting to observation itself. Samuel wanted to dismiss the idea, but he could not find a better explanation. Every time they tried to measure something directly, the result shifted. Every time they looked away and returned, it was different again. Outside the observation station, multiple science teams across Earth were reporting the same issue. Independent telescopes, deep space arrays, and orbital probes all showed matching instability patterns. It was not a local error. It was global in scope. Samuel decided to run a controlled blind observation test. He set up systems to record data without human viewing it in real time. For a short period, the readings stayed stable. Then, the moment the system flagged the data for review, it changed again. That was the moment Samuel felt something he had never felt in his career, uncertainty without explanation. He gathered the team and explained what was happening. The data was not just incorrect. It was actively resisting fixed interpretation. The cosmic domain apparatus could not be pinned down by normal scientific methods because it behaved differently depending on how it was approached. One junior researcher suggested a software bug in the analysis pipeline. Another suggested unknown cosmic radiation affecting computation. Each idea was tested and rejected within hours. Nothing matched the behavior they were seeing. Samuel spent the night reviewing every frame of recorded data manually. He slowed playback, isolated signal streams, and compared independent recordings. Every comparison showed slight, unavoidable shifts. It was like trying to measure a moving shadow that changed shape when looked at too closely. By morning, Samuel was exhausted. His notes were filled with corrections, contradictions, and repeated warnings. Values unstable under observation, measurement collapse under focus, data non-fixed. Anna Reeves asked him directly what he thought it meant. Samuel hesitated for a long moment before answering. He said that if science required stable conditions to understand reality, then this object was not allowing stable conditions to exist. It was not just difficult to understand. It was refusing to be understood in any fixed way. That was when humanity began to accept a new possibility. Not that their instruments were broken, but that their method of understanding was being challenged. And somewhere far beyond the edge of known space, the cosmic domain apparatus continued to exist, untouched, unchanged in essence, yet always different in form whenever someone tried to see it clearly. Anna Reeves had not slept properly in days, but her mind was clearer than ever. The strange behavior of the cosmic domain apparatus was not getting simpler. It was getting worse. Every new measurement, every new scan, every new attempt to study it only made the situation more confusing. Most of the science teams had already accepted failure. They believed the object could not be understood using normal methods. But Anna did not accept that conclusion. She kept going back to the same idea that had formed quietly in her mind during long hours of watching unstable data. What if they were looking at it the wrong way? Instead of asking what the object was, what if they asked what it caused? Instead of moving forward from cause to effect, what if they moved backward, from effect to cause? At first, the idea sounded strange even to her. Science was always built on forward logic. Something happens, and then you explain why it happens. But this object did not behave like normal reality. So maybe normal thinking did not apply. She called for engineer Peter Collins. He was known for working with simulation systems that could model complex space environments. When he arrived, Anna explained her idea in simple terms. Peter listened carefully, arms crossed, silent at first. Then he asked if she understood how dangerous that approach could be. Reverse logic in physical systems was not standard practice. It could produce false structures or meaningless patterns. Anna answered that they already had meaningless patterns. The current method was not working. So they had nothing to lose. That convinced him more than anything else. Peter began building a new simulation system. Instead of feeding it known physical laws and watching what happened, he reversed the process. He started with the observed effects from the cosmic domain apparatus, distortions in gravity, unstable measurements, shifting data, and tried to reconstruct what kind of system could produce them. The first few results were useless. The system generated chaotic models that made no sense. Space folded in ways that broke basic structure rules. Time loops appeared randomly. Entire regions of simulated reality collapsed instantly. Peter almost stopped the project, but Anna asked him to keep going. She believed the problem was not the idea, but the scale. The system needed more layers, more constraints, more patience. So they refined it. They fed in only stable fragments of data, small moments where the apparatus had shown consistent behavior for fractions of a second. Then they let the simulation build backward from those moments only. Slowly, something changed. The simulations began to stabilize in certain regions. Not fully, but enough to form repeating structures. Patterns started to appear, not random anymore, but organized in strange layers. It was as if the system was revealing hidden logic piece by piece. Peter noticed something important first. The system was not just recreating physical space. It was reconstructing relationships between observation and outcome. In other words, it was modeling not just the object, but how the object reacted to being observed. That idea made him pause. Anna studied the output carefully. She saw something even more unusual. The simulation suggested that the cosmic domain apparatus was not a single fixed structure. It behaved like a layered system of rules that changed depending on how reality interacted with it. It was not simply reacting. It was adjusting. The reverse model showed something else too. At deeper levels, the structure seemed to be built around stabilizing broken systems. Where reality became too unstable, the apparatus appeared to correct it. But the correction itself created new instability elsewhere. It was like a machine trying to repair a broken mirror, only to create more reflections in the process. Peter ran another test. He increased the scale of the reverse simulation. The results became clearer. At the core of the structure, there seemed to be a logic system that did not operate on normal physics. It operated on outcomes first, and then constructed the conditions that would lead to them. That meant it was not predicting the future. It was building the past based on what already existed. Anna leaned forward as she saw the results. That explained everything they had observed so far. It explained why measurements kept changing. It explained why observation affected results. It explained why nothing stayed stable when studied directly. They were not looking at a normal object. They were interacting with a system that treated observation as part of its structure. Peter pointed out something else in the simulation. When the system reached higher levels of reconstruction, it began to show signs of awareness, not in a biological sense, but in structural responsiveness. The model adapted to their analysis, changing slightly as they refined their inputs. Anna felt a cold realization forming. If their simulation could influence the model, then the real structure might also be influenced by understanding itself. They were not just studying it. They were participating in it. Over the next several days, the reverse simulations improved. Each cycle of testing revealed more stable patterns. The cosmic domain apparatus was not random or chaotic. It was structured around managing inconsistencies in reality. It acted like a balancing system, constantly correcting distortions across vast scales. But the correction method was not simple. It worked by reshaping conditions themselves, which meant reality near it could never remain fully stable for long. Anna and Peter shared their findings with the wider scientific group. At first, many scientists rejected the idea. It sounded too strange. But the data was difficult to argue against. The reverse simulation produced consistent results across multiple tests. Even Dr. Samuel Price, who had been deeply skeptical, admitted that the pattern consistency was too strong to ignore. The hidden structure was slowly becoming visible. Not fully understood, but no longer invisible. Anna knew they were still far from the full truth. But for the first time since the anomaly was discovered, they were not completely lost. They were beginning to see the shape of something that had been hidden in plain sight all along. Dr. Laura Bennett first noticed something strange during a routine scan of near-Earth space. At first, she thought it was a mistake in the visualization software. The star map looked normal, but small sections of space were behaving differently when the data was processed in real time. She checked the raw feed again. The same issue appeared. Certain regions of space were no longer just empty or filled with normal cosmic background noise. They were forming patterns. Soft, shifting structures that did not belong to any known physical phenomenon. Laura called for a deeper review. Within hours, multiple systems confirmed the same effect. Space near Earth was not changing in a physical sense, but in how it appeared depending on the analysis method. It was as if the universe was responding to the way humans were thinking about it. At first, she did not report it as anything serious. She assumed it might be an advanced sensor artifact caused by the ongoing instability linked to the cosmic domain apparatus. But the pattern kept growing stronger. When Dr. Anna Reeves reviewed Laura's findings, she immediately understood the importance. This was not random distortion. It was structured. It had form. As more data came in, something even more unusual happened. The changes in near-Earth space began to match patterns of human thought and mathematical reasoning. When scientists focused on certain models, the space visualization shifted in ways that reflected those models. When they changed their assumptions, the structure changed with them. It was subtle at first, almost invisible unless carefully tracked. But it was there. Engineer Peter Collins ran controlled experiments to confirm it. In one test, he and his team deliberately thought about simple geometric shapes while observing a section of space data. The results showed faint but consistent alignment with those shapes. Not physically formed objects, but structural patterns in the data representation itself. Laura Bennett stood in silence when she saw the results. She had spent her entire career studying astrophysical behavior, and she had never seen anything like it. Space was not supposed to respond to thought. But the evidence was growing stronger. The real breakthrough came when they tested more complex ideas. Instead of simple shapes, they used abstract mathematical concepts. The response was immediate. The structure of near-Earth space visualization shifted again, forming layered patterns that matched the complexity of the ideas being considered. It was not perfect. It was not stable. But it was clearly responding. Laura felt a strange tension building in the team. Some scientists argued it was still a side effect of the cosmic domain apparatus interfering with observation systems. Others believed it was a deeper interaction, something between human cognition and the structure itself. Dr. Samuel Price, who had once dismissed many of these ideas, now watched in quiet concern. He admitted that the data no longer behaved like simple measurement error. It behaved like interaction. Anna Reeves suggested something that made the room fall silent. She said that if the structure responded to understanding, then it was not just a passive object. It was aware, in some form, of how it was being perceived. Laura Bennett did not reject the idea immediately. She had seen too many impossible patterns to dismiss anything outright. Instead, she proposed a controlled test involving multiple independent teams across Earth. Each team would focus on different concepts while observing the same region of space. The results were undeniable. Each team's observations influenced the structure differently. Where one group focused on stability, the data showed steady patterns. Where another group focused on uncertainty, the structure became more fragmented. Where teams focused on reconstruction, space showed signs of reorganization. It was as if the cosmic domain apparatus was not just reacting to instruments, but to the meaning behind the instruments. That realization changed everything. Laura began to understand the deeper implication. The apparatus was not simply a machine or object. It was a system that included observation as part of its function. It did not separate physics from perception. It treated them as one process. This explained why previous attempts to measure it always failed. Humans had been trying to isolate it from themselves, but it was never separate in the first place. As the experiments continued, something even more unsettling happened. The structure near Earth began to stabilize briefly whenever large groups of scientists reached shared conclusions. Agreement itself seemed to create temporary stability in the system. But disagreement caused distortion. This meant that collective understanding was not just describing reality, it was influencing it. Laura reported this directly to the Central Coordination Team. The response was immediate concern. If thought and understanding could influence the apparatus, then uncontrolled analysis could have unpredictable effects. Some leaders suggested stopping all active research. But Anna Reeves argued against it. She said that stopping would not remove the interaction. It would only leave humanity ignorant of it. So research continued, but with caution. Laura found herself thinking differently now. Every time she looked at the data, she was aware that her interpretation might be shaping what she was seeing. That awareness created a strange feedback loop. Observation influenced understanding, and understanding influenced observation. One night, while reviewing long-range scans alone, Laura noticed something unexpected. A small region of space visualization briefly formed a pattern that resembled a human neural structure. It lasted only a moment before shifting again. She recorded it immediately. When she showed it to Anna Reeves, Anna did not look surprised. Instead, she looked deeply focused, as if confirming something she had suspected for a long time. Anna said quietly that the apparatus might not just be responding to human thought. It might be learning from it. That idea changed the tone of the entire project. Humanity was no longer just observing the cosmic domain apparatus. It was now interacting with something that appeared to adapt based on how it was understood. And that meant understanding itself might be part of the system. Laura Bennett stood before the observation screen again later that day. Space near Earth was calm for a moment, almost peaceful. But she no longer saw it as empty. She saw it as something listening. Something that changed when she tried to understand it. And something that might already know how she was thinking. The final stage of the project began quietly, without celebration or noise. There were no victory signals, no public announcements, and no sense of triumph in the control rooms. Instead, there was silence, focus, and a shared understanding that humanity was standing at the edge of something that could not be treated like anything before. Dr. Anna Reeves stood at the central console, watching the final inverse decoding results stabilize. Months of work, confusion, and repeated failure had finally led here. The reverse models built by engineer Peter Collins were now running in a steady loop, no longer collapsing or shifting unpredictably. For the first time since the cosmic domain apparatus had been discovered, its behavior appeared consistent under controlled human understanding. Dr. Laura Bennett monitored near-Earth space readings. The strange reflective patterns that once shifted based on thought were now settling into stable formations. Not fixed like ordinary space, but balanced, as if the system had reached an agreement with human observation. Dr. Samuel Price carefully reviewed the final data streams. He no longer argued against the idea that reality itself was interacting with perception. Instead, he focused on ensuring that the interaction remained stable. His earlier doubts had not fully disappeared, but they had changed shape into caution rather than rejection. The breakthrough came when Anna initiated the final inverse synchronization test. The idea was simple in concept but extremely delicate in practice. Instead of trying to observe the cosmic domain apparatus from a distance, humanity would align its interpretation models directly with the structure's own response patterns. Peter Collins initiated the system. Across multiple stations on Earth and in orbit, synchronized simulations began to run. Each one used slightly different human thought models, but all were designed to do one thing: match the way the apparatus constructed reality backward from outcomes. At first, nothing changed. The systems ran normally. Space data remained stable. The apparatus showed no reaction. Then, slowly, a shift occurred. Not in the instruments, but in the relationship between them. The data streams began to align across all observation points without conflict. Previously unstable contradictions disappeared. Measurements no longer changed when observed. Instead, they settled into shared patterns that remained consistent across all systems. Laura Bennett noticed it first. She called Anna immediately. Her voice was calm but serious. The near-Earth distortions were no longer fluctuating. They were stabilizing in a structured way that matched the inverse simulation models. Anna watched the central display without speaking. She understood what this meant. The system was no longer resisting observation. It was cooperating with it. But cooperation did not mean control. It meant recognition. As the synchronization deepened, something unexpected happened. The cosmic domain apparatus responded not with signals or messages, but with structural alignment. Space itself began to reorganize subtly around the shared human models. It was not changing randomly. It was adapting in a controlled, stable way. Peter Collins checked every system twice. There were no errors. No malfunctions. No external interference. The change was real. At that moment, Dr. Samuel Price finally spoke. He said that the universe was no longer behaving like something humans were trying to understand. It was behaving like something that had started to understand them back. The cosmic domain apparatus responded by stabilizing its influence range around Earth. Previously unstable regions of space became calm. Distortions reduced. Measurement contradictions disappeared entirely within the controlled zone. Laura Bennett observed something even more important. The system was not simply stabilizing because it had been decoded. It was stabilizing because it had accepted the decoding method itself. Humanity had not forced it open. It had adapted to humanity's way of thinking. Anna Reeves studied the final integration results for a long time. Then she spoke quietly, almost as if speaking to herself. She said that the apparatus had never been an enemy or a puzzle waiting to be solved. It had been a structure that required participation rather than observation. It did not break when humans tried to understand it. It responded. And when humanity finally stopped trying to force meaning into it and instead learned to think in its direction, the system no longer treated them as unstable observers. It recognized them as compatible thinkers. Not broken minds trying to decode an impossible system, but adaptive minds capable of sharing the system itself. The final communication logs from the apparatus did not contain words or language. Instead, they showed stable patterns that matched human cognitive structures. It was not speech. It was alignment. A shared state between understanding and reality. When the system fully stabilized, Anna recorded the final official statement for Earth archives. She spoke slowly, clearly, knowing the words would define the entire event for future generations. "We didn't break the code," she said. "We learned to think with it." The cosmic domain apparatus remained beyond human space, vast and incomprehensible in its full form. But near Earth, it no longer behaved like something unknown or hostile.